a region bounded by two radii, that's plurius for radius, like a piece of apple pie. Just kidding, it could be any flavor, but anyway, what they're saying here is in this circle I had drawn up here, if I put a center here and you draw the two radii, the sector is this inside there. It's like a piece of pie. And we're going to find the area, be able to find the area of that now. Okay, so again, it's another ratio or proportion that we set up. So we say if we want to find the area of a circle, we do the area of a sector, which could be our unknown, or they might give it to us and solve it for another part. Since we're talking about a circle and its area of the sector, we're going to use pi r squared instead of the circumference like we did in this one. See the difference between the two? This is talking about arc length, which is a piece of the circumference, and that's why you use circumference in the denominator. This is talking about a piece of the whole circle, a sector, and we're talking about its area, so we use the area of the circle in the denominator. Just trying to help you memorize these because you're going to have to know them. Okay? And then you set it equal to the measure of arc AB again over 360. So notice they're both, these two are the same in both of these proportions. And so that's what we're going to use to practice with today. Just that. All right, turn the page. 3 problems. Not too bad. Find the area of the sectors. Look at the directions. There are 2 sectors in there. Which piece of would you rather eat?
The bigger one?
Of course. That's a sector as well, okay? Formed by HJK. So there's actually 2 sectors formed there. Let's find the smaller one here. We're going to find this one first. So, area of the sector, I don't know, so I'm just going to put A there. But when I'm doing area, what do I put in the bottom part of that ratio?
2 pi.
No, that's
Pi r squared.
right, pi r squared, because we're talking about the area here. Equals the measure of arc AB. What's the measure of this arc?
100.
100 over 360. And then all you have to do, oh wait, we know the radius, don't we? I should have plugged that in. What is the radius here? 12. I should have plugged that in. Sorry. That's 12. So then you just get on your calculator and you do this cross multiply and divide by 360. Try it out, see what you get. Let's round to the hundredths place. Use your pi button. Remember to use the pi button. What'd you get? This is what I got. Is this what you got?
Oh, I forgot to times it by 100.
Okay.
LOL.
All right.
I got it.
Cool? Okay, we have another sector to do. In order to do the other sector, we're going to need this measure, which is going to be what? 360 minus 100? 260, right? Okay, so then we'll find the bigger sector here now. Area is equal to the same thing, pi times 12 squared. The only thing that changes is the measure of the arc, which is now 260 over 360. And I'll just tell you what that is. That is an area of approximately 326.73 when you do the math. Cool?
What's that number?
362? Nope, nope, nope. I had a little dyslexia there. 326.73.
Actually called this calculator.
Is that what it is? Sorry, because it's numbers instead of letters. Do you have it?
No, but every time I write down like the page number, I always write it wrong and I'll do like the wrong one.
She's really paranoid.
Dyscalculia. That makes sense because it's numbers instead of letters. All right.
She took it
Thank you. Okay.
Email me back if you need one.
So let's see how this one is different. It says use the diagram to find the area of the circle. Okay, the area of the circle S. The area of RSTQ. See how they're labeling this sector with 4 letters here, RSTQ. That area is 48 feet squared, and they gave me the measure of that angle as well. So we need to find the area. So we're going to do 48 over pi r squared is the area of the circle, isn't it? So we just need to find that number there, total. Equals the measure of the arc over 360. When you do this math, 48 times 360 divided by 120, you find out that pi r squared is 144 feet squared. And remember, the area of the circle equals pi r squared, so the area of the circle is 144 feet squared. Make sense?
Yes.
You don't really need to find the radius because you have all the other information. Okay, last one. In this large circular painting, 2 white congruent circles just fit into the gray circle. What is the area that appears gray? So let's analyze this a little bit.
I know how to do it.
I bet you do. I want to make sure everybody looks at it. Everybody look at it and see if you could figure out how you would do this. In order to find the gray area, you probably need to find the area of the whole circle, correct? And then, like a donut, take out these 2 pieces. So if you write that out, gray area equals the full circle area minus 2 white circle areas. So think of it like that. You don't necessarily have to write it out, but I'm just doing it to show you. Yes?
With the, like, would you just do like the radius? Would it just be like
Okay, so if we're gonna
radiuses?
get there. Yeah, it does have something to do with it. Yeah.
Okay.
If you extend this, it's going to be the diameter of that circle, right? Which will be how long? 6. Well, if I write it like that, isn't that then going to be the radius of the gray circle? Which is then, we decided what number? 6, right? So in order to find the area of the gray circle, I would just use pi r squared, and my radius is 6. So pi times 6 squared is the area of the gray circle. And then I got to subtract from it 2. What's the radius of one of the white circles? 3. So I got to do 2 of those, pi times 3 squared. Make sense? So sometimes writing it out like this helps a little bit, filling in what you know, looking at the picture. And that means then that the gray area will equal approximately 56.55 meters squared. That's what I got. Check to make sure I did it right. Good? Do you guys agree? Okay then.